Hey class, this is Dr. Martino again. This is PV Loop video number 3. So in order to expedite some of these upcoming videos, make sure that you go back to video number 1 and video number 2 and then read over and study the basics. Okay, so I'm going to assume that you've been following along and then I don't have to keep repeating the same things over and over again. Now we're going to look at an example of what happens when you have an increased afterload. So first let's define afterload. An afterload is the amount of force, the amount of resistance that is on the outflow side, in this case of a valve. Okay? It's on the outflow side of a valve. So if we're talking about the aorta, right, it's on the outflow side. So if you imagine you have the heart, right, and you have the aorta coming out, right, and you have the aortic valve here. This is, okay, this is the valve. This is where the preload is located in the left ventricle, and then this is the outflow. There's a back pressure that pushes back against the aortic valve, okay? That back pressure is from the arterial pressure. Arterial pressure, okay? In this case, happens to be the afterload. Or you can also think of it as the aortic pressure. Okay, so that's what the afterload is. It's the amount of force, the amount of pressure pushing back against the valve. So in order for any valve to open, right, the amount of force being produced, in this case, by the muscle, the left ventricle here, right, the left ventricle, has to exceed the pressure. Well, what's the pressure at this point where it opens? It's about 80. Okay, so when you have isovolumic contraction, as that pressure goes up, it will not open up the aortic valve until the isovolumic pressure in the left ventricle exceeds 80. Okay, so that's how valves operate. That's how these valves operate. So then the question becomes, what happens when the afterload increases? So simple question, you start with a simple diagram again. You start here at end systolic. You ask yourself if the first question is, has anything changed with the preload? Is preload less? Is preload more? As far as we know, in this specific example, none of that has changed. So you draw. Let me switch. You draw a curve to here, right? And you're going to say that end diastolic volume is going to be the same because preload hasn't changed. The amount of fluid going in and in the chamber hasn't changed. Okay. Isovolumic contraction begins. Okay. And you get to this point, and then you ask yourself, has anything changed in the opening pressure of the aortic valve? And in this case, we've increased afterload. That means that instead of opening up at 80, it might end up opening up at maybe 100, right? So now there's 100 millimeters of mercury pressure in the aortic and the arterial pressure. Your blood pressure's gone up, okay? That's basically what happened. So now your heart's going to have to push that much harder against the valve to open it, in order for blood to flow out. Then what happens? Well, that's changed, so it's going to have to generate more force, right, in the isovolumic contraction. So you're going to get an increased peak pressure, right? An increased peak pressure. So now the question then becomes is does anything happen to this curve, right? The systolic curve. And in fact, the systolic curve did change. And what has happened is that the systolic curve would have come down. Okay, would have come down. And what does that mean? When the systolic curve moves in this direction, that's an increase in resistance. Sorry about this terrible writing. Okay, so there's an increase in resistance. So let's clean this up a little bit for you. So what happens rides up to here, stays over here. This goes up. There is a slight decrease in this. You're going to have an increase in the output. And this will drop. So what does that mean? What does that mean? The area under the curve has definitely changed, right? That means there's going to be this isn't very accurate, and it doesn't have to be very accurate. It's the general gist is what I'm looking for. When you increase resistance, right, you're going to have to use more force to overcome that resistance. So this line comes down. So then the amount of blood that's going to be forced out is going to be decreased by that much. So let's say that this is 90. Okay. The difference between 90 and 75 is 15 mils. Okay. So you get an increase in afterload, which means that the aortic valve opens up at a higher pressure, which means that you'll generate more force, which will generate a greater peak pressure. Because of that resistance, the curve will come down, which means that the amount of blood that flows out, even though there's an increased area here, okay, when there's an increased area there, right, that's not going to make up for this entire area. So you eject less blood because ultimately there's a higher resistance. And that's it. That's all we got. So we'll move on to the next one. Hope this made things clear. If not, listen to the first two again and then listen to this one. Have a great day.